nice morning, a nice day, and thanks for joining this webinar. As already mentioned, my name is Tom Drensky, and I'm basically responsible for Socionext HDPLC promotion in Europe. And before I start, I also wanted to thank very much the IEEE, but also the HDPLC Alliance for giving me the opportunity to present Socionext high-definition power line communication solution. The outline of my talk today is to give you first a brief company introduction, then talk about the basic HDPLC technology, show some solutions we have from Socionext on it, and end with a short summary. So let's start with the company introduction. I now assume that most of you are not very familiar with the company Socionext. And I want to explain that we had the start of business in March 2015, and Socionext basically is a joint venture of the companies Panasonic Semiconductors and Fujitsu Semiconductor, which means even here it states we started 2015. We do have a very long experience, like over 40 years in SoC design and manufacturing. Also maybe worthwhile to mention is that Socionext is currently one of the top 3 fabless design houses worldwide. The headquarter, just a moment please, I have to move this. The headquarter of Socionext is in Yokohama in Japan. The capital of Socionext is over $302 million US, and if you look in the business description, it says that we are doing SoC design and development, including solutions and services. We do employ at the moment more than 2,600 people worldwide. Maybe also interesting or worthwhile to mention is that Socionext had a very successful IPO last year in October in the Japanese stock market. Okay, it's not moving. Okay, here a slide showing the worldwide locations of Socionext. As already mentioned, the headquarters of Socionext Inc. is in Japan, but we also have subsidiaries in America, for example. So we have a Socionext America Inc. with headquarters in Santa Clara. We do have 4 other locations in Asia region, 1 in Hong Kong, 1 in Shanghai. And we have a Socionext Taiwan with a headquarters in Taipei, and a Socionext South Korea with a headquarters in Seoul. And last but not least, we of course also have a Socionext Europe GmbH, where the headquarters are located in Langen, that's close to Frankfurt am Main in Germany. And I'm personally working out of Maidenhead in the United Kingdom, which is very close to London. Here, a business scope, or what kind of business unit or main segments Socionext is working on. So we do have a business unit looking into data center networking areas. We do have an automotive business unit where we look in advanced driver assistance systems or human machine interfaces. We have a lot in industrial applications looking at automation and office solutions, but also other things like imaging, where we have camera applications and solutions, and augmented reality or virtual reality. Now, of course, if we talk about HDPLC, like today, we do have a dedicated business unit called IoT Radar Sensing. And on the next slide, I will have some further information on what they are doing. So basically, for the IoT segment, we do have 4 different kinds of applications we are looking into. So one of them is broadband receiver solutions. Another would be smart sensor solutions. We also have automotive communication solutions. And here again, like I said, for the HDPLC, we have the IoT communication solution. For all of these applications, one thing is in common. We do make or design and manufacture compact, very low power CMOS circuits. They are all very low noise, and they are all optimized designs for the requests and needs of our customers. Okay, now going into the HDPLC technology itself and a brief overview. So the target solution of HDPLC is, of course, historically speaking, coming from having a power line and adding up a signal onto the power line, so ending up into a power line communication, so overlapping signal, which can be used for communication. This kind of communication can be transmitted via any kind of cable, for example, flat cables, twisted pair cables, coax cables, power line cables, but as already mentioned, basically any kind of media would do to transmit HDPLC. So for the target, solution. Basically, I see that HDPLC is there to solve existing issues in communication. So with it, we can enable data or communication exchange, any kind of monitoring or controlling, switching on or off any device or system using existing cable or network infrastructure is possible with it. Miyake-san already showed a lot of use cases actually. So, and JP also added on one of the underwater applications. So for me, maybe some more use cases for you to look into. Basically, historically speaking, as it's power line communication, I think everybody, if he hears it, thinks first about smart metering applications or smart meter gateway or smart grid application. So here I think nowadays its main focus is on getting high data rates for smart meters, and most important, having the a very secure and long distance communication available. Other areas now very popular is in photovoltaics or solar power. The HDPLC could be a very good fit because you don't need any individual inverters and can control directly without communication lines. An area of use case predestined for PLC is of course the upcoming IoT and any kind of products for the Society 5.0, including of course then smart home applications, smart building or smart city or any kind of industrial complexes. Here, of course, most important is having a stable and a secure communication can be used for monitoring and switching of devices and systems or entire networks. Another application or use case I see, or which is very popular recently, is in terms of street lighting. So it's not only being now implemented to control lights, dimming it or putting it on off, dependent on people walking by or the traffic which is passing by. Nowadays, they're also adding a lot of sensors to a post. And with the sensors, you could then also track, for example, the weather, air pollution. You can do some traffic monitoring or speed control. Additionally, also nowadays, people mount video cameras on it for image footage, or even put panels and displays where you can then put traffic signs on it, or basic kind of information can be provided to passengers passing by. So that's a very interesting area. Another very interesting area is, of course, anything what is in tunnels, shafts, or pipes. So because that are closed environments where wireless technologies have often a lot of difficulties to really penetrate. So there HDPLC could be the perfect solution to get communication or monitoring or controlling done. Here a small use case as an example how HDPLC could work or help you. So you can see here, for example, a laptop and another device you would like to connect to, could be a speaker or a video camera or something. And basically, if you're at home, probably you could use a wireless connection to connect these two kind of devices. Or if you are in industrial facility or in the office, probably you do have some Ethernet cabling available to connect this kind of things. But just imagine, for whatever reason, the wireless connection is not working or an Ethernet cable is not at the moment available. What to do. So it would be very easy then to use, for example, our HDPLC solution. So here in this picture, you can see one of our evaluation kits which are available. So you connect just one cable from the laptop to the evaluation kit, which is the master terminal here. From there, you go with a cable just to a plug-in of a power supply anywhere in the house or in a facility. On the other side, you take again a plug and cable it back to a receiver kind of a terminal evaluation kit, and this one is connected then to your end device. And with this, you can see if these other communications are not available, you can directly use PLC as a main kind of communication channel. In this case, laptop over the PLC chip using power line cable, and then going back to the PLC chip to the outcome. So it could be a main kind of communication connection, but it could be also used for bridging or supporting technology. I personally always hear that there is a big fight between PLC or Wi-Fi, which system is better or not. Basically, I think we should see it not as one solution to be used. I see it more like having a coexistence between the solutions. So you could have a backup or secondary system. So if the wireless connection is not working, or if Ethernet cable is not working, you could easily implement a PLC, right? And have a backup circuitry, because that's what the end customer at the end wants, a very safe, stable and secure power line. And it doesn't care where it comes from. Okay, here a small slide deck about the feature of the solution. On the left side, you can see the HDPLC solution of Socionext. On the right side, just as an example, Ethernet and Wi-Fi, and what are the pros and cons. So of course, you can say that the HDPLC is very low cost and it's very easy to adapt, right? So you use existing power lines as here, or you can use existing TV or coax cable. So basically, there is no installation needed, or yeah, everything is available, so it's very easily to bring up and to control. Furthermore, to mention here is that HDPLC, our chipset, for example, can connect up to 1,000 nodes. So you can connect many kind of applications to it. HDPLC does offer very high security. This was already mentioned because it had this AES 128 encryption included into the system. We do have high-speed comms, which is very stable running. So of course, Ethernet is also a solution you can use, but yeah, no security is guaranteed. Also for the length, it's kind of difficult to implement it. And of course, you have to put some money on the table to get the installation needed. For Wi-Fi, it's very easy to install, but again, security might be an issue. And yeah, dependent on stability, yeah, I think HDPLC is definitely something which could help out here. Then coming to our Socionext solution itself. So thanks to JP, he already explained a lot about the standard and what is implemented in the standard. So it's easier than for me here to go through. You can see here basically depicted the generations of HDPLC so far. We did have 4 generations and 4 different kind of chipsets available on the market. And here are the items which are changed, or functions which were added on over the time. So basically the first HDPLC, first generation chipset, came out around 2010 timeframe. The second generation came out around 2013 timeframe. The third generation was around 2015 timeframe. And now with the fourth generation, it started on development in 2021, is now basically readily available. As HP said already, the HDPLC fourth generation is completely compliant with the IEEE 1901 2020 or the ITU-T G9905, and has many new features and flexibility added on. So new features are, as said, the half mode and the quarter mode for long distance. We have additional available bandwidth, and also again here to extend range, we can have the so-called carrier spacing with half or carrier spacing quarter modes. For the phi rate, we have now 250 megahertz per second. If you look in the past, it was a little bit lower. And for the available bandwidth, there was no selectivity available at all. And if we look at the distance of the HDPLC solution, you can see without multi-hopping, with the newest generation, you can reach for the time 1 mode 400 meter, and if you have the long distance mode, you can reach up to 1000 meter. If you imply now multi-hop, so you can add up to 10 hops in one system, you can then of course extend this reach from, for example, 400 meter to 4 kilometers. Or if you use the quarter mode, you can have even up to 10 kilometers, which is like a real big extension compared to anything available beforehand. Here, a brief introduction on the chip itself and on the specification. Here you can see a small picture of our chipset. It's called SC1320A. It does include, as you can see here, for example, a CPU here in green, which is an ARM Cortex-M3 running at 125 megahertz. We have many kind of interfaces here depicted on the left side that supports various of connections like SPI, UART, or GPIO. Of course, we do have an HDPLC 4-core, which you can see here depicted in blue. We have the microcore, PLC Fine, and PLC MAC. already mentioned was that the max file rate is 250 megabits per second. The distance max is 10 kilometers if you use 10 hops. Another feature of the chip is that we have a single 3.3 volt power supply into the chip. And we do have built-in DC-DC converters, so which means if you use this kind of chipset, the circuit board around it does not need so many circuits, in not so many components. So you have an optimized BOM or reduced BOM, and this, of course, will reduce also cost. For the power consumption of this chipset, it only uses 200 milliwatts typical, because we use some kind of special in-house technology for this one, which is far below that anything else which is available at the moment in the market. And also, if you look at the package size of the thing, it's QFN 7x7 millimeter, which is a very, very small form factor. I think no other solution at the moment is that small available in the market. Here's some product features on long distance com. Again, thanks to JP, he already explained about the modes and how it works for the standard. So basically, we do have the X1, which is compatible with the HDPLC 3 generation, and with the HDPLC 4, we have this new kind of modes and channels selection available. If you look now, for example, on how such transmission looks like, if you look at the frequency, for example, and how the received power is behaving in terms of cable length, you can see this kind of graph. So this applies for the X1. So of course, if the cable is very short, you will have a very good received power level, and with that, of course, you can transmit very well. But if you increase now the cable length, for example, to 50 meter, which is the blue one, or to 100 meter, which is the red one, or to 200 meter, you can see that, the cable is attenuating the signal very much. The receive power is very low, and at the end, basically, there's not any signal going through, and you cannot transmit any data really. So, and then the feature of HDPLC 4 comes into place, which is, for example, depicted here. So here, that's an example how a transmission path or signal noise ratio feature could look like. So what is basically happening with HDPLC is that there is a pilot tone sent into the line, and this pilot tone is then checking and tracing the channel and check on the characteristics, and based on that, you can see then a plot and see where you have good SNR and where you have a bad SNR, for example. And then using the signal strength and power level and the wavelet OFDM signal, you can allocate the highest possible needed modulation format for this area. So you say, here's a very good SNR. So you can say, I select now this band, and I put all the power and all the modulation into this area. And then you can have, as a result, the bottom graph where you see the frequency and the power, and you can see with good NSR, you can transmit here then the signal with very good modulation factors. The right plot here is something basically JP also showed already, showing the basic behavior of cable length with throughput using this different kind of channels. So you have an X1, which is this line. You can see that you can get throughput up to 400 meters. If you use, for example, this X2 band, then you can extend it from this one up to maybe 600 or 700 meter. And if you use, for example, X4, then you can reach up to 1 kilometer. Regarding the development status of our chipset, so evaluation kits, evaluation samples, or yes, are available. And we are also mass production ready for anybody who wants to implement or use an HDPLC solution. Of course, if you engage and have an NDA, you can have all documentation, manuals, and anything you need with it. So as a summary, maybe I would like to say that Socionext does have unique selling points for its LSI. We do have a very small package size, we do have a very low power, and we do have a very state-of-the-art device. We are conform with the latest IEEE 1901 or 2020 ITU-T G9905 standard, and it's the worldwide first device using fourth generation HDPLC evolution. Our device is very easy to use and control. It has a very high security encryption for data transfer. It enables, as shown already, long-distance communication. It has multi-hop and multi-mode function and can connect up to 1,000 nodes. Our chip also includes all the necessary IoT device interfaces like UART, SPI, Ethernet, MAC, RM2, and supports also basically existing industry protocols like BACnet or Loanworks. And since we are a member of the HD-PLC Alliance, of course, the Alliance itself enables a complete ecosystem and interoperability with all kind of HD-PLC devices and systems available currently on the market. So with that, I think I conclude my talk, and I would thank you very much for listening.